All right. Welcome back, boys and girls. Drive-through confessionals, special day after Super Bowl edition. And what we're doing here today for all you kids that are sleeping at home because you stayed up too late last night is helping you with worksheet number 8. I'm going to show you how to do a number of the problems from worksheet number 8. So actually, we're going to start out with number 3. Okay? The directions say, draw an angle with the given measures in standard position, and the measure is 580 degrees. So, 580 degrees. Well, that's more than a complete circle. So we have to get an idea of what that would actually look like. So what we want to do is subtract 360 from that. And what does that leave us with? 220 degrees. So our terminal angle is going to look like a 220 degree angle. But we have to do a full rotation. So we'll do something like this. Since it's positive, you go counterclockwise. So we've now gone 360 degrees. We need to go 220 more degrees. Just always keep in mind where 180 is. This is an 180 degree rotation. It's half of a circle. So we go to here. And so now we need to go 40 more degrees because 220 is 40 more than 180. And this is by no way an exact process. We're just looking to know that you conceptually understand that this angle right here has rotated 580 degrees. Think of it like tires, okay? Tire rotations, just continuously traveling in circles. So we'll also do number 5. I'll do this on a separate graph. Let's just get a new page. And we choose to do number 5 because now it's a large negative number. Negative 450 degrees. Okay, well again, it's hard for me to imagine what that looks like because it's not a number that makes sense to me because it's not less than 360. Or the absolute value of it is not less than 360. So what I'll do here in this one is I'll add 360 degrees. And that'll get me a coterminal angle, and that's going to be a negative 90 degrees. So just imagine if this is 90 degrees positive, then this will be 90 degrees negative. However, I've got to do more than just 90 because it's negative 450. So again, any point on here, it doesn't matter. Now we're going to go clockwise with our rotation. So where we've just done that, that is negative 360 degrees. We need to keep going down to here. So you can think of that like a negative 360 degree rotation with negative 90 more, and that is how we got to negative 450. Okay? All right, the next set of directions. Find an angle with a positive measure and an angle with a negative measure that are coterminal with each angle. So, number 7, this is the easy version. You guys are good at this. So if you think about what we just did, coterminal means it shares the ending result with the same angle. So if we wanted to find another angle that looked just like 65, what do we add? We add 360, and so the first answer to that is 425 degrees. So what that means is that if you rotated 425 degrees, you would be in the exact same position as if you rotated 65 degrees. Just think skateboarding, okay? If you do a 360 in skateboarding, it would be the exact same thing as if you did a 720. You would end up in the exact same position. You would just be rotating more. That's all we're doing. Okay? It says it also wants a negative answer. So there you'd do 65 minus 360 degrees. And that's going to be negative 290. Okay, negative 295 degrees. Okay? So, to find coterminal angles, we add 360 or subtract 360. Sometimes we have to add 360 twice or 3 times. It doesn't matter. Just keep rotating them. Okay? Number 8 is more difficult, and it's not more difficult because it involves radians. It's because radians involve fractions, and you guys just struggle with adding fractions. That's nothing new, but it's okay. We can do it. So 2 pi over 5. Remember that, oh, that's 10? Let's do 10. That's what I meant to do. Thank you. Okay? Well, remember that 360 degrees is the same thing as 2 pi radians. Okay? So what we can do here is add 2 pi to it. Okay, here's where the fractions come in. You guys forget how to add fractions. It's been a while, and honestly, when you learned it the first time, you probably weren't great at it anyway. What we can do, the only way we can add fractions is if we have a common denominator. We have to make this have a 5 on the bottom. But in order to put a 5 on the bottom, I have to multiply by 5 on top. I just multiplied this thing by 1. I multiplied it by 5 and I divided it by 5. And that's just like multiplying it by 1. I'm allowed to multiply it by 1. So now it looks like 2 pi over 5 plus 10 pi over 5. I did 5 times 2 to get 10. And so this answer would be 12 pi over 5. Okay? Keep working at those. You'll get better at them. We'll have the key ready. You guys can check your answers. But we're not done with the problem yet. We also need to do, let me just do a little curtain here, 2 pi over 5 minus 360 degrees, because we got to find a positive answer and a negative answer. So don't get confused. I'm just following the directions. I'm doing a different thing now. Well, again, let's multiply by 5 and divide by 5. We're allowed to do that. And so that gives us 2 pi over 5 minus now 10 pi over 5. So it gives us negative 8 pi over 5. Now we have a negative answer, a positive answer. They're coterminal. So we have followed the directions. So we're moving along relatively quick. If you're watching this at home, just pause it and rewind it if I did anything that confused you. Okay? Now we're going to hit up number 13. It says, rewrite each degree measure in radians and rewrite each radian measure in degrees. So 13 says 18 degrees. And remember, when we go degrees to radians, you need to have this in your notes. And remember, our assessments are open notes. So have it organized so that you can rely on this on Wednesday. You take your degrees, you multiply by pi, and you divide by 180. So, for this, we're going to multiply by pi over 180. So what you get is 18 over 180 pi. Okay? I've been encouraging you to just pop 18 fraction 180 equals into your calculators. And If not, you can just use your good old-fashioned number sense, and that's going to be 1/10 pi, or more commonly written as pi over 10. Okay? So if you have radians, just remember radians is another way to measure angles, but it's more useful, or it's more likely to be used in terms of rotation more so than like the angles in a triangle. Okay? So if you want to have degrees and you're given radians, you just multiply by the reciprocal. So take your radians, multiply by 180, and divide by pi. So now let's do number 18. We need to change 5 pi over 2. We need to change that to degrees. So we multiply by 180, and we divide by pi. That's nice. Now we no longer have pi involved with our answer. Really, this is like 90 times 5, so it's 450 degrees. Okay, we're going to do one more, and that is number 21. Find the length of each arc, round it to the nearest tenth. We got a circle. Looks like the radius is 3.5. And our angle is pi over 2. The nice thing about writing things in radians, remember a radian is simply the length of a radius traced onto a circle. That's what a radian is. Okay, it's one radius long. But you may not understand that, and that's just fine. Arc length can always be found by radius times the amount of radians in the central angle. Radius times radians. So for this one, our arc length will be 3.5 times pi over 2. Look, in here, if you wrote it as 3.5 pi over 2, I'd have absolutely no problem with it. You get full credit. Okay? Someone else might want you to clean that up. A lot of people don't like decimals and fractions, and I get that. So you might have to multiply by 2 over 2, and that's going to give you 7 pi over 4. But if you didn't get that last step, you're not confused about the radian process. You're just confused about fractions. Don't sweat it too much. At some point in your life, you won't have to deal so much with fractions. Unless you plan on building things around your house, then you're going to have to suck it up and learn, because that's how it works. That's how our system works. All right, thanks for paying attention. Check this out anytime you need a little extra help. Boom.